So here, what we're going to do is we're just going to build a very simple regression model. We're going to do a model of the form basically calories, right? We're predicting calories from fat. So you see at the very bottom here, I have hopefully eventually what we'll do is print out the estimated B0 and B1 for the for the model, but that's what we're doing, right? So given fat, I want to predict the caloric consumption for a particular person. We've taken care of importing some of our modules up here at the top. So I've imported NumPy and the matplotlib using star import. So let's go ahead and get started and actually see what we can do. So let's say I want to get the data set that we're going to use. It's sort of a CSV file, but I don't want to use it as a CSV file. I mean, you could at some point. You could import it as anything, but really, I just want to import it so I can get the things and then do some manipulation with them. So I'm going to use a built-in function. It's called gen from text. This is just going to take a CSV file and basically turn it into a NumPy array. Right? All I need to do is tell it what the name of the file is. Now here you'll actually have to put the file path. I've actually stored it. I stored the file in the same folder that I actually am creating this, so that's a way around it. But nutritionstudy.csv is the name of the file. And I want to tell it the delimiter is it's going to be is a comma, right? Because a CSV using a comma to separate the cells in there. If we want, right, we could print it out and take a look at it. Hopefully this works. If not, I'll have to go back to the drawing board to figure it out. Oh, it did not like my gen from text. Oh, okay. I see what the issue is here. So I just need to go up here, turn this into gen from txt. Right, it's generating from a text file. So there we go. Hopefully that did it. Oh, it doesn't like this thing at the bottom. But you get the basic idea of what this looks like. Now, you'll notice that what it's done is it turned it into a NumPy array with float entries. So any of these things that NaN, this is just not a number. I mean, what has happened is we can look at the original data file. We can look at the original nutrition study file. And you notice that any of the little boxes where you see the NaN, well, that corresponds to something that was a string, right? So like it doesn't understand ID, age, smoke, any of the no's or yeses, anything like that. It's not going to recognize them. And so what it's just going to do is basically fill in a not a number. But that really doesn't matter for our purposes. If we want, we can go ahead and just strip off the header row because what it did is the way it stored it here for us is not what I want. So if I wanted, what I could do is just say that data is equal to data, and I could say it's the first row. All columns. So I'm going from row 1 to the last row, and then all of the columns. And if we print it out now, right, notice that it just it stripped off that top row, what the header row was initially in the file. So now we can actually start working with it. Now that we've seen what it looks like, we could expand it and look at it more, but I just have it pulled up in Excel, so we can just go ahead and look at it in Excel. So if this is column 0, where the ID is, then age is 1, 2, 3, 4, 0, 1, 2, 3, 4. So I care about column 5 and column 6 only. So what I want to do is I want to just put the X values into a single array, right? And then the Y values into a single array so I can do something with them. So what I could do is I could say that Y is equal to, right, I could just pull out the ones that I want. Now remember, I want all of the rows, and the column I want here is, I believe it's column 5, and then X is all of the rows, column 6. So just make sure that that's what I wanted. So go back 0, 1, 2, 3, 4, 5 here, 6, yep. So 5 is for Y, 6 is for X, and that's what I have. That's what I've done up here. Right? So now I have the data loaded in. So now what do I want to do? Well, I want to create some variables. I'll call B0. Right, and B1 that I want to find. I'm also going to need to do, well, I'm going to need to do a little bit of computation, right? So I need to find these computationally. So when we were doing this sort of like reducing things down to very simple form, right? We have, well, that the B1 variable there that we want to find, that's equal to a sum of like x, y, right? So it's the sum of x times y minus x bar times y bar divided by the sum of the x squares minus n times x bar squared, right? So what I want to do here is I'm going to make sx and sy, or sxx and sxy, and from that, I'm just going to set them equal to 0. I also want the I'm gonna call something x bar, right? That's just going to be the average, right, or the arithmetic mean of the x values. I'll call something y bar. That's just going to be the arithmetic mean of the y values. And then here I have something else I want to call n. And n is just going to be, I mean, since it's the same number of data values, it could be the length of either of them, either the x or y. It doesn't really matter. But I'll need these for my computation. Now, the way I'm going to do this is I'm just going to write up, I'm just going to write something that will loop through and add up the sx x and sxy's. I mean, we could do this in a number of ways. We could use matrix multiplication if we really wanted. We could also just use a for loop. I'm just going to use a for loop to do it. So here I'm just going to say for I in range, right? So notice here that was helpful, right? What I want to do is I just want to say s, right, sxx plus equal, right? This is going to be x. The way I'm going to do this is just xi squared, and then here sxy, that's plus equal, right? It's going to be xi, oops, s I, and then y I, right? I got to put multiplication between them. So there we go. And then at the end, right, that's pretty much done there. It's summing those things up. And then at the end, all I'm going to do is subtract off the appropriate things that I need to subtract off. So, right, sxy is equal to sxy. And then I'm just going to subtract off n times x bar times y bar. And then I'm going to say sxx, that's just sxx minus n times, right, x bar squared. All right, so there we go. So now I need to compute. I'll say B0 and B1. So B1 is actually the easier one to find first, and then you can actually compute B0 just by doing a substitution in with B1. So like B1 or B0, I'm sorry, that's just equal to Well, it's just the quotient of the SXY and the SXX. So this is SXY divided by SXX. Right? It's the sum of squares for XY's and sum of this, well, this is the sum of the XY's and the sum of the squares of the X. And then, right, I'll say I'm sorry, this is B1. This is B1. Then B0, that's just equal to Y bar minus B1 times X bar. And that's it, right? So I pretty much have this done. If I wanted, I could run this, and it should hopefully. I mean, it's entirely possible it will give me an error here, but it should give me this regression model, right? And this is the one right. This is what I expect to find for my regression model. Now, what would be nice is if I had actually print this out, and we can take a look at it. Okay, so I'm going to have to plot. I'm gonna do a scatter plot with the data values, and then I'm gonna do a line plot with the others, with the predicted values, with the regression line. So what I'm gonna do here is actually just let's see. I'm gonna create something called X's or XS. That's just going to be equal to minimum X to X. I'm going to go by half. So this is just creating a bunch of X values, right? I'm going to call something Y's. The Y's, right? So each Y value is just going to be equal to B0 plus B1 times the X values. Right? So that's it. Now I can do the plotting. So now I'm going to plot. So I'm just going to call the scatter function, and that's going to just be the X and the Y. And then next I'm going to plot with X's and Y's. And let's see, did it give me what I want? Well, this is unusual. I have not had this happen before. Oh, I see what happened here. Alright. Well, that's an easy fix. I just needed to make it a range of values. So there it goes. And that's not particularly nice looking, so I'm going to plot this with a different color. I'll just make it red. Right, so it stands out a little more. So there we go, right? There's my best fit line, right, which is in red, and then here are the data. All done.